folks. For a start, one of the big problems with conferences where everyone speaks standard international English is that people come from Scotland and Ireland and start talking slang. So probably most of you don't know what a lovey is, but in Blighty, a lovey is a slang word for an actor, because actors always go, "Oh darling, sweetie, lovey." And so the reason this is LuvvieScript is because it's an Erlang dialect that implements actors in the browser. And there used to be a law in the world of Erlang that all projects had to have the letters Erl in them, or the word Erl in them, and got kind of bored of that, so I thought I'm going to break away and name it something proper. The other reason it's called LuvvieScript is because I really would like to be sued by the estate of Elizabeth Taylor, because that is the publicist's dream. So I'm desperately using photographs of Elizabeth Taylor, the great actress, and if anyone knows a lawyer in California, please sit them on to me. So the first question you're asking is why would you want to write a dialect of Erlang that runs in a browser? What problem are we trying to solve by writing Erlang in the browser? And the problem that we're trying to solve is the problem of delivering software continuously into production at a cheap cost, low impedance programming. If we can have an Erlang dialect that runs in the browser and Erlang OTP on the back end, we can have smaller teams that deliver software. So if you go back to 1999, when I was the chief architect at IF, our stack at IF was JavaScript in front end talking over DCOM to an IIS server speaking VB, dropping out onto SOAP with a message handler written in C++, which was picked up on the back end in a J2EE container over Oracle, and then speaking MQ series to 3 different flavors of mainframe operating systems, one of which Halifax had written in 1968. Right? So in order to get a piece of software into production, your minimum team size was about 17, plus an ops team of another 12. And as a result, we spent $100 million. So in the modern world, we're trying to reduce that, and we do that by eliminating software impedance. And we've kind of seen this model appear in Node.js, JavaScript both sides, ClojureScript and Clojure with the same language on both sides. And so LuvvieScript is part of that movement towards mono-language stacks. It's quite common now people have 2 language stacks, you know, Ruby on Rails and CoffeeScript, or Erlang and JavaScript. But it's how do we reduce that? So what we're trying to do with LuvvieScript then is write a DOM scripting language for web pages that talk to Erlang OTP servers. So it's not Erlang on the V8 JavaScript machine. You know, it needs to be capable of running client and server side, so that you can present pages to search engines, which require pre-built pages to operate for SEO. So it needs to be a strict subset of Erlang that should run on the client side, server side if you need to, but it isn't an implementation of the Erlang virtual machine running in the browser, and it's not, you know, I say Erlang on a JavaScript engine. And the reason it's a dialect of Erlang is because the operating environment you're in is radically different. At the back end, you'd expect to have high concurrency, tens of thousands, you have very lightweight concurrent processors, your code is shared, you have hot loading and supervision. On the client side, you have a completely different environment. Your typical concurrency is somewhere between 9 and 25 objects that you would concurrently model on a web page. Your concurrency cost is high. It's a web worker. Web workers share no state when they load JavaScript. You can't control restart. So code changes by page refresh. You have no ability to manage restart. So the operating environments in which you're running are radically different. So what we're trying to make is the surface the same and the underlying stuff completely different. And this is roughly a sort of operating model of what we're trying to build. I haven't got very far with it, but this is roughly what we're trying to do. Essentially, you're trying to design a system that will basically be offline first. So it needs, the typical failure mode of a website is my train's gone into a tunnel, it's not working on my phone. So you need to operate in that environment, and you need to put a variety of components in. And the aim is that effectively you're trying to make the entire browser appear like a C node to the back end. So you just send a message to the browser without knowing It's over HTTP. And I'm going to go through these components in a bit more detail. The key thing with all architectures is to separate the ilities from the alities. The ilities are the things that we all share in common: reliability, scalability, failability. And the ality is functionality, which is my ality is different from your ality. So we all share the same ilities, and we all have different alities. So in the world of alities, everyone writes their own web page. So the part that matters is this schematic web page. And you see how I'm laying out the concurrency. Your typical web page has a header, a main body of something, maybe some ad workboxes, and a footer, and maybe a menu. Those would be your concurrent objects. They'd be represented in the browser by a web worker. They'd have their own data models. And the tiling supervisor is the process that decides how to lay your page out. That page looks like a web page. On a mobile phone, that would be a single column. The adverts would be thrown away. The menu would be swapped for a mobile menu. So the tiling supervisor's job is to say, hey, I'm running on a mobile phone. What do I need to start? I need to start the components that match that. You'll need to have a mailbox that handles message passing between the web workers. And so that's kind of, this part is what the end user would then be writing web pages, and the rest they would just take out the box. So what we have to do as language designers then is build the remaining parts that would be used by everybody. So the idea is that you would just simply have JavaScript libraries that would do the mailbox, the tiling, the page rendering, and then all your caching for local storage and your communication to the back end, and also the library that sits on top of Cowboy on the server side that receives these messages. Because you really just want to be able to say, send a message to the main page of Gordon Guthrie, and it will find my browser and tell it to just receive a message. So that's the sort of architecture and approach. And it's an OTP-ish dialect because we don't want people to write raw Erlang, we want them to write servers or in a server style. So your objects should be written where they will receive in a state object which contains the model of the HTML they're rendering. They'll get a message and who it's from, and they will then operate on the state and hand it back to hand it back in the normal gen server way, and the mutated state will then be re-rendered on the page transparently. So the person who's writing the front-end Erlang never talks to the DOM, doesn't touch the DOM, doesn't know anything about the DOM, all that's abstracted. And what you're then doing is normalizing the interaction modes that you have to handle. You're not going to have complicated callbacks. How many people here have written JavaScript? How many people here have cried whilst writing JavaScript? Okay, so you all know what I mean when I say callback hell and all this sort of ghastly, unreasonable, blah, blah, blah. So what we're trying to say is all the events that I need to deal with in the front end, they should appear to me in the same way, whether from the DOM, another web worker, or from the back-end server. I should just get messages to handle. But the thing that really makes this work, all of this is illusionary until you can get source maps. Source maps are now supported as standard in Firefox for about 6 months and in Chrome. So without source maps, you literally do not get the ability to debug. I'll just try and find the web demo. Hold on. Sorry, I should have. I just need to put in a website, so it'll be 2 seconds.
There's no internet connection here.
Oh, isn't there? Oh, shag.
I don't have.
Okay, we don't have that. Okay, never mind. Now, I'm now stuck on a Mac. I don't know how to do anything. How do I get the window back? Okay. Well, if you go to luvv.ie, the Lubbie site, you'll see a screenshot of the browser with Erlang in the debugging tools, right? With source maps. Oops, hold on. Oh, sorry, I'll find that page. With source maps, basically, it generates a JavaScript that executes, but when you step through the JavaScript, it maps it back to the original source in Erlang. So you can set breakpoints in Erlang, you can watch the code executing, you can apply what. So effectively, it becomes a development environment where the browser is actually running Erlang. And if you don't have source maps, you literally have nothing. All you have to do is then browse. I mean, CoffeeScript kicked off as the first compile-to-JavaScript language to get popular without source maps because it was a dialect of JavaScript. And so the people who used it could write in CoffeeScript and debugging JavaScript. If you try to do that with Erlang developers, you'll just totally waste of time. It's not going to work. So source maps are quite critical. Now, the two biggest pain in the necks about doing this has been getting source maps and getting an Irish domain. Even though my OLA's from the Free State, trying to get LuvvieScript.ie took 8 or 10 weeks of like a domain reseller who stores your password in plain text. You think, what part of my intellectual property are you guarding, you half-wits? But anyway, source maps are a big pain. And they're a particular pain in Erlang because the Erlang syntax tools don't contain column information. So you have to manually add that in. Now, there are some changes going through from Anthony Remains trying to get them into the OTP toolroom. If you can try and push those through into OTP syntax tools, that make life easier. Okay, so how are we exactly going to do this? We do this by trying to do as little work as possible, and that means reusing existing tool sets. Basically, what we're doing is not writing a full programming language, but transpiling an abstract syntax tree in core Erlang abstract syntax tree into a JavaScript abstract syntax tree. And this means I can use the Erlang syntax tools to do my lexing parsing AST generation. Then instead of outputting JavaScript, I can generate a JavaScript AST, which might be ECMC script 6 or whatever, and then I can use the very rich JavaScript syntax tools to convert that to do things like put in temporal recursion, which you generally don't get in JavaScript. You have to mutate the program to do. But I can use tools to do that without having to write it. And then in the end, I can then generate the JavaScript from the AST. So that's roughly the approach we're taking. Now, it goes through core Erlang for a couple of reasons. One of the reasons is core Erlang is a language which is designed to be human readable but optimized for machine writable. You can write it by hand, but I've never met anyone who does. And it sits inside the compile tree as a target for compiler writers. And by going through core Erlang, it means that when we get LuvvieScript working for Erlang, it will also work for Elixir, it will also work for LFE, it will work for any of the other compile-to Erlang languages. So this is a fairly simple Erlang program, and core Erlang is slightly different. It's highly regular. You can see how it's related to Erlang, but it's clearly not Erlang. And it's the previous page was a whole program. This page is the top third of the same listing, so it's 3 to 4 times more prolix than Erlang. But on the other hand, it's much, much, much more regular. So it only has 21 primitives. So the only flow of control primitive is case. There's no if statement, there's no guards. They're all done by case statements. Pattern matching is done by case statements. There's the two primitives in yellow, apply and primitive operation primol, are basically two giant sacks into which you stuff lots of Erlang. Apply calls a function. Lots of the Erlang VM, what you take as native code in Erlang, is actually just calling Erlang functions. And so you stuff a whole load of stuff in there, BIFs and lots of things in the Erlang module that you think are part of the language. And primitive operations like GC, there's a whole load of stuff stuck in there as well. So it's not a very, very big language, and it's nice and regular. So particularly it's separate. The classic problem with Erlang and trying to understand it is when is it the equal sign let, or when it's a pattern match, and when is it an assertion of value. And sometimes it can be both at the same time. If you're pattern matching a tuple, well, one of the variables is pre-bound and the other one isn't, the equal sign has multiple meanings. Well, all that disappears in core Erlang. So that's why we go through core. And the core Erlang AST is quite well documented. There's good syntax tools, and it looks like a series of Erlang records. If you look at this, you'll see down here, C_var, and then in the list there's 8 in the file. These are the line numbers of the original source. To get source maps, you need to get column information in that AST. So you have to generate a token set, map the token set back to the source code, and then walk through and re-annotate this code with the column information, and that's a pain up the arse. But what can you do? So a lot of wrestling with that. And then once I have this AST, I then have to do the old hammer it, kick it, batter it about, and turn it into a JavaScript AST, which is basically a large nested JSON structure. So that's kind of the sort of the wrestling. We now have an end-to-end tool chain that does that, and it's basically working. So I think 7 out of 21 primitive operators in core Erlang I've got coded up. So it's simply a matter of working through that in a systematic way. The test suite is pretty straightforward. You write zero-arity functions that return a value. They compile into JavaScript, they compile into Erlang, they're both executed and the results compared. So you're looking for identity testing against Erlang. So it's very easy to write a test. You just write an Erlang module and hook it in, and then it fails if it runs, which it doesn't. But you get the principle. It sort of spits out vaguely Node.js, but given that I can't program JavaScript and I've never programmed Node, I hope there's nobody here who's going to point out, well, I know it's not Node-y, but at some stage it will be vaguely Node-y. So, it does start producing. This is actually the compilation of that original Erlang program. You basically have to put switch statements in for the case stuff and just go through things like that. And there are some complications because in Erlang, a function with different arithmetics, 2 different functions. In JavaScript, they're not. A function's a function. It can take an arbitrary number of characters, an arbitrary number of arguments, and it's up to you. They may or may not have meanings, or they may or may not have. Anyway, it's quite a very, very different approach. Haven't yet got to putting in fun syntax and closures, but I'm sure I'll be reading the ClojureScript source code when I need to do that. The source map is a fairly ugly thing. The thing at the bottom is the numerical map transcode. It's written in a video compression algorithm to make it short. It's entirely incomprehensible. The specification is incomprehensible. It's a complete nightmare, and the ES Code Gen library does it for you as long as you put column and line in the AST. So somebody else's pain and tears. So trying to write that yourself is just beyond. It's just hopeless. But so again, this is the actual source map. The way we do it is by using the native structure of Erlang. An Erlang module is only contains 3 separate categories of things: a module declaration, which is mandatory and ignored. It has to be there, it has to be correct, and nothing else happens to it. But there's then attributes, export test, and then the function declarations. Those are the only 3 components of an Erlang form. And the attributes are one of the sort of hidden gems of Erlang. Essentially, they're arbitrary Erlang terms which have a meaning imputed to them at a different point in the software cycle. So the standard ones you're likely to see are define, include, export, spec type, author, date, version. At any given point, tools which take part in the production of Erlang bean code will maybe use the map, maybe use the attributes. So define, include a pre-compile expansion. There's some compile time attributes, things like author and version of runtime tools. The dialyzer, which happens post-compile, uses specs in a different way than the compiler uses them. And essentially, you can stick anything you like in attributes. So a lot of the stuff that we need to do to get a running JavaScript system, we basically we can stuff into attributes. So because web workers in the browser don't share code, you need to specify and preload all your dependencies. And we'll be doing that through require attributes. So anyway, it's kind of a Google Fizz. You can do quite a lot of stuff there to get that done. The other thing is we're trying to put, the aim is to have a standard pure functional data model, which is what you'll be mutating as a developer. And that basically, you can see from this definition, that's a pig's ear record where it contains a list of itself under the inner attribute. And so effectively those can be considered as opening and closing tags. So div, span, h1, etc., etc. So an h1 tag can contain a list of other tags inside it, which might be div, span, blah, blah, blah. And you would then subscribe to events on that model, which could either be DOM events like on click, or jQuery operate gives you pseudo events, cross-browser events, like if you get a on focus and something and an on change, it presents it to you as a synthetic event. So the aim is that you will simply mutate on this data structure, and the presentation CSS mapping will be done through classes, and the first cut will be Bootstrap, be using data models that have Bootstrap classes that you can then give you proper presentation. I think there'll probably be libraries that sit above the basic model, so there'll probably be a forms library that will generate forms, and you just put in a series of fields and types and it will create a form that matches that. But I haven't quite worked out how that's going to work yet. But that's the intention, that you instead of having this ghastly DOM stuff, we don't know what's going on, you simply operate on a pure functional data model which you can then iterate over. The other big issue we've got is types, how to handle types. So JavaScript doesn't have an integer or a float type, it has a number. And integers are represented by floats. Clearly there's a big num versus 32-bit issue there. JavaScript doesn't have atoms. Arrays kind of look like lists, but maybe not. How would you do a tuple? What about binaries? So I'm still sort of wrestling with type stuff. My thinking at the moment is probably I'm going to define JavaScript objects, an atom object, a list object, and then I can write the compiler cheaply, and then at some later stage figure out how to implement them efficiently. But efficiency of computation isn't my primary thing. Size of JavaScript library, I think, is more important. So the roadmap really is to get primitives working, which with the test suites, which I'm working on. Once we've got that will produce a stack busting dialect of Erlang where recursion is called by calling itself inside JavaScript. So you can blow the stack. Then I want to start finding the right JavaScript transform library to eliminate, to put trampolining in automatically in the toolchain so that it stops stack busting. And then after that, I'm going to start implementing the server architecture, and then finally build the runtime system that handles communications. And there's going to be some complications in trying to make it look like C node. It's not at all clear that you'll be able to build you could do the naive thing and say every browser will be represented locally by every component in the browser could be represented locally by a process. So you might have 9 PIDs running locally, which I could send messages to, which would be proxies for elements on the web page, but I don't think that's going to work. So I'm probably going to abstract away the process side of it. So you'll have an API like a gen server API to send messages, but users will be identified by their signed in their session ID or their email account, and you should be able to write in your Erlang code, send gordon@vixo.com this tuple message, and that should just straight through the browser. That's the plan. We're in the Beam community, so we're going into the Google Summer of Code, so if you've got any friends who students and want to work on JavaScript mentored by people, come and join the Google Sign of Code, and like to see you, that'd be good. And don't forget to follow me on Twitter. You'll get, if you follow me, you'll get a variety of stuff, including some Erlang and some nonsense. If you follow LuvvieScript, you'll mostly just get LuvvieScript and a bit of, and sometimes I forget which Twitter account I'm in, so small quantity of nonsense. And you can go to the website, Lovvie. And that's it. What's the question?
Question?
Yes. You know, I write JavaScript for most of my day work, and I have some problems with source maps. I tried JavaScript and CoffeeScript, and source maps are quite useless right now. Maybe they will be in the future because debugger won't stop in the place you suspect it will, or even it won't stop at all. And you know, sometimes it's easier to debug code without source maps. It just disrupts, and it's difficult to go to the original JavaScript file to see what happened really. So I just don't think the source maps are that important right now.
Yeah, I mean, source maps are. I think source maps are going to be a work in progress. How to do that cross mapping of the one to the other is quite difficult. And if your language is radically different from JavaScript, the whole what constitutes what is going to be quite painful. But I do think going forward we'll need. I mean, the JavaScript that comes out looks so different. There will need to be something. But I'm kind of a console log IO format debugger anyway, so there's a. But I don't think source maps need to be in there. But I mean, I know CoffeeScript has been wrestling with that issue for a number of years, and it's getting better.
You know, I have no idea how CoffeeScript community managed to make source maps, but they use Google Closure compiler, so I think it affects the source map a lot. Maybe they could convince Google Closure compiler somehow to generate the code, but I have no idea how they made it.
I just use the tools I get with JavaScript TST. So.
And how far it is from the real? For example, if I would like to make a dashboard, live dashboard of how current state of the project is from that.
Sorry, I can't. I'm a bit deaf actually.
You said that you are planning to implement the backend architecture of the server and so on. For example, if I wish to do a simple dashboard web page of my Erlang application current state, so what steps should be done? What steps should I do to get it done?
Okay, I mean the project at the moment is still very, 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 very primitive, so a lot of components aren't in. But I would ideally I'd like to be able to have a system where you could define a record that you could store in Amnesia that would, from that record definition, it would generate an Amnesia schema, a data object, a form to edit that, the web page associated with it, and push that out. And so that I'd like to have a really easy way to build simple form-based websites. So I'd like to get there, but there's still a lot of uncertainty. There could be a lot of experiments on the way to actually getting working websites. It's still quite a long way away, but it's quite fun.
We have time for one more question. Okay. Thank you very much.